So I'm just writing this down.
All right. And tell me if you don't remember the formula.
So what I first will have to like try and draw a triangle.
It'll help to have a triangle.
Okay. And so if I draw just a triangle, does it have to be like? It doesn't have to be accurate, does it?
No, just a sketch.
Yeah. So if I here draw a triangle, and then. So would I need to do something like um would I have to do like x squared equals to like 6.5 squared plus 8.7 squared minus um 6.5 times 8.7 no minus 2 times 2 sorry
Mm-hmm.
uh cos 100 and then just square root that whole thing.
Yeah, and then just square root the answer. And let's take a look. So it was two sides, angle between, and it involves the third side. Side squared plus side squared minus 2 times side times cosine angle between. Any questions? That's good. Find the size of the smallest angle. Okay. How do I do this one?
Okay. So if you just draw it again, would you then, and you put 3, 5, and 6, would you then have to somehow work out each angle and then from there obviously just find out say which one's the smallest?
So I think so. Let's try to get lucky about this one.
Oh, would you do something? Sorry, would you do something like cos? Would you use the cos formula here?
Yeah. I'm just thinking though, which angle of these might be the smallest?
I'm guessing. Uh, would it be 3 and 5?
Let me see. My guess is this is the biggest one because it's opposite the biggest side.
Yeah.
And so my guess is that this is the smallest one because it's the opposite smallest side.
Okay.
So let's do cosine rule for this one.
Okay. So, well, I'll just do cos A.
And do you know that formula?
Yes, yeah.
Okay.
So, will it be cos A equals to will it be 6 squared plus 5 squared minus 3 squared?
Yeah.
Over 2 times times 6 times 5. And then would you just do A equals to cos minus 1 of that?
Yeah. And so the special one was the 3. That was the special one. And then arccos, and it was 29.9. Yeah, so you were right. We had to do all 3. But in fact, to get the second angle, we could have used the sine rule, which is a bit simpler. And then to get the third angle, we could have done 180 minus these 2, which is much simpler. Or we could have used the cosine rule 3 times.
Yeah.
And my guess was this is opposite the smallest side, so it looked like it was the smallest one. Bearings, y at A level. Okay. Let's try. Alright, better try it.
Okay. So do you need to use a protractor here or no?
That would be for like a scale drawing. I don't think it'd be a good idea.
Okay.
So I think try just doing a sketch, and then I'll sketch and see, and we'll compare.
Okay. I'm not really sure, I think.
Okay, so if B is on a bearing of 60 degrees from A, so let's say this is A, point north, turn clockwise, stop when you hit the line. So that's approximately 60 degrees there, and its bearings, so they're calling it 0, 160. This is B. So it's 60. It's on a bearing of 60 degrees and a distance of 4.8 kilometers.
Yeah.
Oh, and then a ship C. Sorry, a ship C is 4.8. Is that right? This one's 8 kilometers. And then ship C is 4.8 from A on a bearing of 18. So it's going to be like that. That is 4.8. That's ship C. Okay, so you have to find distance.
Oh, right. So will that be something like a squared equals to 4.8 squared plus 8 squared minus 2 times 4.8. times 8 cos. Oh wait, and then cos 60.
We
Oh,
need this angle in here.
so will that be 42?
Yep, I believe so. 42. And then you'd square your answer. Let's take a look. 4.8 squared, 8 squared, 2, 4.8, 8 cos 42. Yeah.
Okay.
Grand. Yeah. Any questions there?
No.
So bearings, my bug bearings, GCSE. Okay, well, let's try this one. Looks like a good one.
Okay, so um, okay, so if we draw a triangle again, and then label each corner A, B, C, then so AB is X, BC is X plus 2, and AC is 5, and the angle ABC is 60. Then will it be, so to find X, would that be something like 5 squared is equals to x squared plus x plus 2 squared minus 2x x plus 2 cos 60.
Yep. So basically, we have a quadratic to solve.
Yeah.
I'm taking a gamble with the calculator. A quadratic could have 2 solutions.
Yeah.
If I get a negative one, I know it's wrong.
Oh yeah. Shall I try the calculator as well?
Yeah, you can. Have to remember. So option calc solve n. And equals is shift decimal point. Has a yellow equals over it.
No, it gave me a syntax error.
Graphical calculator. Change cos 60 to times cos 60.
So okay.
Able to edit it.
Okay, so if I write 5 squared, and then how do I do the equal sign here?
Shift decimal point.
Shift decimal point, yeah, and then
And the x is this x here.
okay, right. I got 0.
Shouldn't. Did you do solve in?
Oh no, I didn't. Sorry. So how do I do the solve thing?
Option and
Option.
calc.
It's gone a bit weird. But I think that's just me. I think I tried the same mistake here somewhere. Yeah.
And so you can see mine, and I'll
Yeah.
include a thing. 5 solve n 5 squared equals, then all the stuff, and you can see 2 solutions. One is minus something, and then one is 3.6904. 0.69. Yeah, any questions there?
No.
And you can do it just a long way with that one. Let me see. Okay, try this one. Sorry, someone's at my door. Let's see. Boat P is 600.
So,
There's nothing to that one. That's just 20 degrees there,
right. Yeah.
and then it's just straight.
Yeah.
Easy. Let's see this one. Use the cosine rule to show that it does not contain an obtuse angle. What is an obtuse angle?
Is that an angle between 90 to 180 degrees?
Yeah. So bigger than 90, smaller than 180. That's fine. Just same thing. Go do cosine rule 3 times. Okay, this one looks alright. Okay, let's try this one.
So I need to get the length DC. So would I have to split the quadrilateral up in half to get 2 triangles? Okay, so do I need to find the middle length and then use that middle length to find the bottom length? So what I do? So a squared equals to 8 squared plus 10 squared. Minus 2 times 8 times 10 times cos A2.
And once you know the red length, how would you get the bottom one?
Would we use that length to then. Oh wait, could you just do the area of a triangle like base times height or something? Oh wait, no. Oh, could you do Pythagoras theorem?
Yeah, be Pythagoras. And which one would it be, the plus type or minus type?
Minus.
Yep. Is it worth finishing that?
No, I don't think so.
Okay, that's all right. This is the good type, I believe. Okay, so, and it's a show that, is it? Oh no, it's a find the value. Huh. Okay.
Okay. So. So would we have to do something like x squared equals to x squared equals to x plus 2 squared.
Hold on.
So,
We just need to make sure that it's definitely x squared and not one of the other ones squared. Did you do a sketch?
yeah.
So you're probably right. Let me just make sure. A to B. A to C. B to C is x. B. A. C. Aha. Is that one? Yeah. Okay, go on.
X squared equals to x plus 1 squared plus x plus 2 squared, and then minus 2 times x plus 1 times x plus 2 times cos 3/4.
It's not cos 3/4. The cos of the angle is 3/4.
Isn't that? Oh, times cos of 3/4. Wait, so I'm cos b. Oh, so does that mean I need to get cos a equals 3? Right. So would I then? So does that mean that I need to do cos minus 1 or something?
No. Usually you'd put in like cos 60 or whatever it is. You are told that the cos of the angle is 3/4. So it's just times 3/4.
Okay. And then, what do I just need to put into my calculator?
It'd be so much easier if
Yeah.
you can.
Okay.
Oops. So option, calculate, solve n, and then just go from there. That's the x. Shift decimal point for equals.
Yeah.
And if you're in any doubt, you can put time sign in between stuff.
Yeah.
I won't. I'll just try doing it with it. Although we'll definitely need a time sign after the brackets. Times 3/4.
So it gave me chord -1 and 4.
And so, which is it?
4.
X equals 4. X equals 4. Yay, 6 marks. Okay, any questions there?
No.
Shape B and C. So part A is fine. How about part B? It's okay. That was alright.
Yeah.
So cosine rule.
Probably a tick, I think.
We can do sine rule if you want, or something else.
Yeah. Sine rule.
Okay. Okay, how about this one?
So. Okay, so I'm guessing I need to draw out a triangle again.
Yep.
And so do I need to label the angles here?
You don't have to. The angles are always opposite this side. So if that's big A, then that's little a. I mean, just angle A is 30, angle C is 40, something like that.
Um, uh, so what I need to do, sorry, sine 40 over 8 equals to sine 30 over BC.
Yep. And you could just calculate it.
Yeah. And so it's just taking a bit of time here. It says x is 6.22.
22 centimeters. There we go. Grant. Any questions there?
No.
So side opposite angle, side opposite angle. This time it's an unknown angle.
So I got draw a triangle again, I think.
Mm-hmm.
And uh, so would you have to do something like um, sine 35 over 5.2
Mm-hmm.
is equals to some length over x.
Which angle is it? Okay. Which side do we know?
Yes, equals. We know 3.8 and we know 3.8 as well.
So let's use that one. And we'll get sine C.
And then, so I'll just use my calculator here again.
Yep.
And so, all right, and then you just do 180 minus those two angles.
Yep.
So, I got that C is 24.78. And then, uh, and then we need to do angle ABC is equals to 180 minus 35 minus 24.78.
Yep.
And so it's equals to 120.22.
All right. Roughly 120 degrees. Roughly 120 degrees. So if you don't, it won't always match up with that angle or that side. Just do it with the one that does and fill in the blanks that way.
Yep.
Okay. Let's see. That one's okay, I think. Let me see. 9, 8 of sine x. Yeah, this is a bit. We'll do this one. How about this?
So draw a triangle again. And then um, so would you have to do something like Um, Sine x over 9 is equals to sine 25 over 8.
Yep.
And then do I just need to do sine x equals to 9 times sine 25 over 8?
Yep. Well done.
So I got 0.475.
475.
Yeah.
Okay. And B.
And then B. Um, okay, so if in the triangle it's 25, so would I need to do would I need to do sine minus 1 of 0.475?
Yep.
So and that'll be equals to 28 point 36.
Let's say 28.4 degrees. Two possible values. What's that about?
So would that be like, for example, it's giving us 2 decimal place. I'm not really sure.
This is called the ambiguous case. It's when the angle could be acute or obtuse. So I kind of did my best to do it down here. I had to spin it around a bit. I don't quite know how to draw it. But basically, either it could be... I don't quite know how to draw it. But the... Yes, that would work, I think. So this B, see how this is 9?
Yeah.
It could also be that, let's say, if you drew a line like that, that's also 9. And so what we found was this acute angle here. It could also be, hang on, B, C, A. I think it's to do with these two angles. And so the second angle would be, how do you get second answer with sine?
Just making it sine minus 1.
That's first answer. Second answer? You do 180 minus the first one.
So 180 minus 28.4, which is 126.64.
0.64 degrees. And so angles on a straight line add up to 180. And also when you have your sine graph, it repeats every 360. It's symmetrical about 90. And so 180 minus first answer is how you solve those. 28.39, is that what you said? Yes, 28.4. And that's... Did you do 180 minus?
I might have not. Yeah, I think... Oh, no. I did. Yeah, that is right. Sorry, it's meant to be 159.64.
Okay. Yes, and so for the ambiguous case, it's 180 minus, so it's the first and second possible answers, because it could be this triangle up here, or it could be kind of a more obtuse triangle that's a bit like that.
Yeah.
Where A is like that. Any questions there?
No.
Okay. Let's see. Bearings. I think it's alright, you just draw it, really.
Mm-hmm.
This looks like the ambiguous case again. Yeah, let's try this. So first they describe the diagram to you, then they ask you to find stuff.
Okay. So would you need to first of all do 180 minus 65?
Okay.
And that'll give 115. And then do you need to do something like sine theta over 4 equals to sine 115 over 7.
That'll work.
And then just put into your calculator. So that will be equals to I got 31.2. And then like 32. So would you then use a 30? Would you do something like sine 115 over equals to sine 15 over something?
So we've got a few unknowns there.
Yeah.
Any other ideas?
I'm. Oh right. Will it be that? So do I need to do 15 plus theta? So 15 plus 31.2, which is equals to 46.2. Wait, so would I then need to do 180 minus 46.2 minus 31.2? No, minus, sorry, 115.
Okay.
And then that'll give the missing angle, which will be 18.8. And then would I then do using that? Oh, and then will it be something like I need to find BD, don't I?
We need to find AD first.
So, sorry, is it okay if you write down the 115 degrees, please, on the triangle so I know what we've got and stuff.
Yeah. 150, yeah.
Okay.
Might have to be something to do with this small one. Do we have the length of AB?
Should we work out AB?
I think my instinct is AB because that's a side that's in both triangles. Like it's in the... or I suppose we could find this angle and then that would give us this angle.
Oh, yeah. So 180 minus 115 minus 31.2, which will be equals to 33.8. And then 180 minus 33.8 is equals to 146.2. And then if we do like do we not need AB here? Or
We don't know what AB is. But AC is 7.
alright. So does that mean that if we just do sine 146.2 over x, it'll be equals to sine 18.8 over 7.
Yeah.
And then use the calculator for that.
Yeah.
And so I got x is 12. Yeah.
12.0?
Yeah, I got 12.08.
Alright. Centimeters. And C.
So, oh, could you do? Would you just do sine 15 over CD
Mm-hmm.
equals to sine 146.2 over 12?
Yeah.
And then CD equals to CD equals to 5.6.
5.6 centimeters. So our first one was 31.2 degrees. That was 5.62. And then so it's starting to round. So we have to keep, although the final answer is to 3 sig fig, the working out, you'd keep the 5. So part B, we were saying it's 12.0, but it was actually 12.1.
Yeah.
And then same with this one. Like if you decrease the accuracy, then it's going to be fine, like 5.6. But if you want them all to 3 sig fig, keep it to 5 sig fig. 2 more than you need to. Any questions there?
No.
Okay, I thought it would eventually go out a little bit. Let's see. Diagram. AC is that. BC is that. Sine A is that. Sine B is that. Value of x. So I was just rearranging. Sine A over A equals sine B over B. And you just rearrange it using the sine rule, and then just rearrange. Yeah. Make x the subject. Let's see this one. Given that sine y is that, show that that's that. So that's similar. You're just subbing it into sine rule and rearranging. Yeah. So this one is similar to the one we did where it's got the 2 triangles together. This is a bit easier actually because this is a right angled triangle. So you can do SOHCAHTOA and Pythagoras. Yeah, so sine rule, what do you give yourself there?
A tick.
Well done. And then you have all the other stuff that comes